So as all of you know, India is targeting to be a developed country by 2047. So lots of development in infrastructure in private sector and public sector will come up, and that will be on a very fast speed too. Here APL Apollo also proposing tubular steel building construction for fastest construction. As an builder, as an government agency, as a structural consultant, whenever, as an architect, whenever you think about a building, I think you consider only 4 points. These are the points: speed, quality, cost, and building should be environment friendliness. So all these points can be catered with APL Apollo tubular steel building solutions. So how we can achieve speed, cost, and quality, I'll brief in a next presentation, next slides. So APL Apollo is India's largest tube manufacturers, and we are proposing buildings on tubes. So we give the tubes on cut to length material between 5 meter to 12 meter. That's how we can give the ready material to the fabricator company, to the construction company, which can reduce their time because they have no need to do extra fabrication work. They just have to finish their sandblasting, paint, and nut bolt connection and have to erect at site. By the time everything will be done, foundation will be done at the site, factory will be ready in the factory, and just need to erect at the site. And zero welding will be at site, everything will be done in the factory. So as of today, tubes usage is limited up to bracings, secondary members, facade structures, etc. So why people are not using tubes as a complete building structures? Because size, the reason was that there was unavailabilities of sizes. Now we are producing 1000 by 1000 up to 40 mm thick tubes. And we are producing this in a very much quantum. We are producing 10,000 metric ton per day. Earlier, larger MOQs was required for any sizes. Now we can produce, because of the DFT technology, we can produce 10 metric ton minimum quantities also. Earlier, wastage was higher. Now we can give cut to length material between 5 meter to 12 meter, any size required. So that's how we are increasing tubes for the verticals, high-rise buildings, for heavy structures also. Where you can use tubular construction, any building, like hotel, data centers, railway stations, airports, any commercial building, residential building, warehouses, factory sheds, anywhere you can build your building on tubes. That's how we are saving time. In conventional RCC, a slab time is approximately 20 to 24 days. Here we can achieve slab time is 8 to 10 days. So that's how we are saving 50% time in skeleton to skeleton comparison. And we are getting additional 2% carpet area also, because column size will be smaller comparatively RCC buildings. Environment friendliness, which I discussed. So this is the global study that 60% of carbon emissions, 30% of carbon emission comes directly from the construction industry. So if we move to the steel structure, that can be reduced by 60%. So steel structure is a bit costlier comparatively RCC. Straightforward, if we look after, it is 200 rupees per square feet costlier, if we comparison structure to structure. But if we comparative it complete building, there will be approximately 2 to 3% extra. But if you consider time as a money, which is actually money, then you can cover this cost. this additional 200, 250 rupees per square feet cost very easily, because you can finish your project 50% faster comparatively RCC building. Also, you can save 2% carpet area, 1 to 2% carpet area as per the grid size, as per the type of building. So if you consider the real estate value also, so again you can cover these 200 rupees extra which you invested in the early stage. So steel building is not a new concept. This is 100 years ago. Empire State Building was built on steel, but that was on conventional H-beam, I-beam. So what's new? New is tubular construction. Here we are giving ready material, factory made material to the fabricator company. Just they have to finish that, and in tubes building will be much aesthetically better. And speed also will be much better comparatively conventional technology, because fabricator can get the material on a very high speed. We have done some case studies for some different grids. This is 6.3 meter by 6.3 meter grid. So you can see in the bottom there will be a tonnage saving of 10% and carpet area of 1%. So why it is tonnage saving? Because tubular steels can bear more load than comparison to H-beam, I-beam. So capacity of tubes is much better than tubes. That's why there is a optimized building. In grid 8.3 meter by 8.3 meter grid, there is again 12% or something, 1% carpet area additional you are getting. In 10.3 meter by 10.3 meter grid, again 10% tonnage saving and 1% additional carpet area. That's how you are getting the additional carpet area. If we go, this is G plus 12 story building. If we go with the tubular construction with CFT, the column size will be 1500 by 1500 up to 12 mm. But if we go with H-beam, then because of the aesthetic building, you cannot leave that is naked. You have to do is encasing. And encasing again a masonry work. Then you have to jacket it with reinforcement bar, with shuttering, and with concrete. So you are doing again the same work which you were doing for the RCC conventional buildings. Here you have to do the CFT only, and you have no need of like outside encasing, because these columns look like a RCC column, rectangular or square. So that's how you are getting additional carpet area. So there are some myths about tubular construction. Bolted connection is not possible. But in tubes, bolting connection is possible. Just you have to give them expansion of beam. You have to put a plate of expansion and the beam. Then you can put a easily bolted connection. High raw material cost. So because we are producing in a mass, then cost also reduced because of the capacity. Unavailability of bigger size, which I already mentioned. We are producing 1000 by 1000 40 mm thick tubes. So you can go up to any limit, 30-story building, 40-story building with this size. Even we are providing stud also inside the tubes. So this is again a myth that tubular construction required a on-site fabrication. Here in APL Apollo Tubes, we are giving 100% on factory construction, factory fabrication, zero welding at site, 100% nut bolt connections we are giving. So these were the 6 hospitals when we conceptualized tubular construction. Then Delhi PWD approached us for faster construction of hospitals in COVID time. They approached RCOP. So RCOP suggested PWD that tubular technology is the only technology where we can do faster construction as of today. So these were the six hospitals in Delhi, 6 different locations, 18,000 metric ton material, 22 lakh square feet area. All the hospitals completed in from manufacturing tube to erection, all hospitals completed in 90 to 100 days. It is, I am talking about skeleton to skeleton comparison. So everything is completed in 90 to 100 days. Then we have done this military engineering services hospital projects. This is dormitory, residential project for the troops. So these are 3 buildings. These are again on 100% tubes. We started this project, Nanavati Max Hospital, these 3 basements on tubes. So these are again on 100% tubes. We have supplied first time 500 by 500 at these projects. This one more project in Greater Noida, that is the expansion of GLA University. So that is on RCC. So above 3 floors are on 100% tube. This is the real image of final projects. This is IIT Roorkee projects. So during this complete hospital projects, then MES projects, we went to IIT Roorkee many of the time for proof check. So IIT Roorkee that time was planning for an administrative block. So they were that much impressed, they have decided to go with tubular construction, and that building they decided on tubes. Project is started, and that is vetted from 2 IITs. IIT Roorkee itself was the PMC for this projects, and they have vetted from IIT Delhi also. This is again one more project which we have done on tubes. This is MIT University campus in Hyderabad. This is G+5-story building with Ahluwalia contracts. That is completed in a very shorter period. We are doing hospitals in northeast region. We are doing 2 hospitals. One is in Imphal, one is in Shillong. The design is done by HSCC, sister concern of NBCC. They do hospitals projects for NBCC. So these are the rims of northeast. Both projects started 100% tube. Then this one mall projects that is in Bangalore, 100% tube, already completed projects. This was the project designed by CP Kukreja, a prominent architect in Delhi NCR. That was commercial building of Indian Oil Corporation. The tender was on 100% tube, tender won by Swadeshi contractor, one of the contractor in Delhi. So that project will start soon. Railway station, as I told you, there will be a lot of infrastructure will come up in next few years, and that will be on very fast speed. We have designed this project for New Delhi railway station. We went to RLDA many times, and that much convinced. They have mentioned in the tender document that steel members should be a hollow structure members of 350 grade. That is tender extract, which you can see in blue line. After that, we have designed Tirupati railway station. That is first railway station of India, which is on 100% tube. Concourse launching is already done. Earlier, like some of the builders, some of the EPC contractor and structural consultant were not convinced for the erection methodology. But that railway station launching is done with a very small agency and very easily, and successfully concourse launching is done. This is first railway station of India on 100% tube. After that, we are working on like 10 to 12 railway stations that will come up on 100% tube. Out of which Secunderabad, Jalna, Aurangabad, Kasi, Bangalore cantonment, CST also, we are trying that will come on 100% tube. So people are using tubes easily now. Even all us, our structure consultant are convinced now. So this is a live image of Tirupati railway station after launching of concourse. We are doing airports also. So lot of airports also coming up in India for redevelopments. So this is Jodhpur Airports. That is on, again, tubes. We have designed this with, again, Swadeshi contractors. So because Swadeshi was the EPC contractor, we give some design supports also. We have in-house design team. After that, we have done Prayagraj airport also. That is with Vishal infrastructure. The EPC contractor Sikka Associates is the architect in that project. So that is again on 100% tubes. We have done some warehouses also. These are some warehouses which we are doing with Birla Cements, Star Cements. That is housing project in Mumbai. We have designed it for Capacite. They were planning to bid for some of the projects here for EWS people. So we have designed that, but anyhow, this project is on hold from government side. These are some studies. Steel versus tube. That is the 40,000 square feet warehouse comparison. You can see the tonnage in tubular and built up. 81,000 kg, and this is 1 lakh approximately. That was the oxygen plant completed in COVID time also, completed in 15 days because of tubes only. These are industrial set. You can see the EOT also running on these tubes. These are some typical connections details which required on tubes. So why are not there are too many buildings on steels? Because India market is very cost sensitive. People don't think for the timeline, but now time is changed. Everyone is looking for speedy works. Even government also looking for the time-bound projects. So now scenario is changed. These are some tubular design of airports. So as I told you, we are producing 10,000 metric ton. We have 11 plant, pan-India. We have 800 dealers, 50% market share. That's it from my side.